Hey Math Stars! Today we're going to learn a lesson about a different kind of factoring. It's called factoring a sum or difference of cubes. Before we dive into this, let's review the kind of factoring that we learned in the first semester. So as you know, the first thing we always look for when we factor is a greatest common factor. If the leading coefficient is negative, you want to factor out a negative. So in this first example, we can factor a negative 2x out of that first term. Dividing by negative 2x, we're left with x minus 3. You always want to check and make sure that the terms in the parentheses have nothing else in common. They do not, so we are done factoring. Okay, the next kind of factoring is called a difference of two squares, and you do this obviously when there's two terms. They both have to be perfect squares, and there has to be a minus sign between them. There is no sum of two squares factoring unless we're using imaginary numbers. So we're not going over imaginary numbers today, so we're not going to do any sum of two squares. So we are going to factor this into two binomials. We're going to square root that first term. That gives us 5x. Make sure you square root the 25 and the x squared. Let's square root the last term. When you square root a monomial, you divide the exponent by 2. So when we square root that y to the 8th, we are left with y to the 4th. You divide the exponent by 2. One term gets a plus sign, one term gets a minus sign. Looking inside each of these factors, they no longer have a common factor and they are not factorable anymore as a difference of two squares. The y to the 4th is a perfect square, but the 5x is not, so we can't factor it anymore. Okay, the next one is product sum method. You guys are really good at this one. Just something to keep in mind is this last number, the constant, is going to be your product, and the coefficient of the x is going to be your sum. So if we look for two numbers that multiply to 90 and add to 19, we get 9 and 10. If we make them both positive, they're going to add to 19 and multiply to 90. Okay, we haven't done much with grouping, but it's a way to factor a cubic function. And you want to do this. You can do it other times when there's 4 terms. So you want to look for 4 terms in order to do grouping. It can actually be grouped if there's like 6 terms or 9 terms or 8 terms, but for the problems we're doing, you're mostly going to look for 4 terms to group. So grouping only works if you can find a greatest common factor in the first 2 terms and the last 2 terms, and when you factor those out, the remaining factor is the same. So you'll see what I mean. And those first 2 terms, we're going to factor out an x squared. That's their greatest common factor. What remains after factoring out an x squared? X minus 3. The last 2 terms, well, since they begin with a minus, there's a negative coefficient on the x, I'm going to factor out a negative 7. So factoring out negative 7 gives me x minus 3. Make sure when you divide out that negative 7, the sign changes on the 21. Now this guy, the x minus 3, this becomes my new common factor. So let's factor out that x minus 3 first. Removing the x minus 3 from this first expression, I'm left with an x squared. Factoring out the x minus 3 from the last expression, I'm left with an x squared minus 7. Okay, we're done. But what you want to do is you want to check this quadratic, where the x squared is, and see if this can be factored again. It cannot, since 7 is not a perfect square, so we are done factoring. Okay, the last one, let's go ahead and factor it by guess and check. So we're looking for 2 monomials that multiply to this 2x squared. So it's going to be a 2x and an x. Those multiply to 2x squared. We need now 2 numbers that multiply to this 5 here. We'll worry about the signs in a minute. So there's different ways you can go with this. We could put the 5 in the first binomial and the 1 in the second one. Let's check and see if that works. It's called guess and check for a reason. Multiply the middle product and you get 5x. Multiply the outer product and we get 2x. Can those products be combined to give us 9x? No. So we have to switch the location of the 5 and the 1. So switching the location of the 5 and the 1, now our outer product is 10x and our inner product is 1x. Can those be combined to give us 9x? Indeed they can if we make the 10x positive by putting a plus sign in front of the 5 and make the 1x negative by putting a negative in front of the 1. So we're done factoring. Let's move on to the new kind of factoring. It's called sum and difference of cubes. You wrote that title down already in your journal. Okay, so I have listed here the perfect cubes because those are important when we factor a sum or a difference of cubes. So these are perfect cubes as well as any variable with an exponent divisible by 3. That would also be a perfect cube. Okay, so pause the video and get those cubes written down in your journal. So here's how we factor this. I'm going to teach you an acronym that we're going to use to factor this. We're going to end up with a binomial and a trinomial as our factors. What you want to do here is, well, first thing we always do is look for a greatest common factor. The x cubed and the 125 do not have any common factors. Let's cube root that first term. And we're going to put an x here. Cube rooting 125, we get 5. And then we're going to bring down the sign. Okay, now we're going to actually ignore the original problem and we're going to use an acronym called SOFAs. SOFAs, and I'll tell you what that stands for. The first S stands for square the first term. So the first term in this binomial that we made, we're going to square it. So squaring that first term, we're going to get an x squared. O in SOFAs stands for opposite sign. So we're going to put the opposite sign of the binomial we created over here on the left. So the opposite sign of this minus sign is a plus sign. In SOFAs, next comes F. F stands for first times last. So we're going to look at the binomial on the left and take the first term, which is the x, and multiply it times the last term, which is the 5. So x times 5 is 5x. Next one is always add. So we're always going to be adding there. And the last S in SOFA stands for square the last term. So if we go to the binomial on the left, that 5, let's square it and get 25. So when you do SOFAs, you're always going to be going back over here on the left and you're going to be referring to this binomial and using it to square the first term. Give the opposite sign. Do first times last. Always add and square the last term. Now this trinomial we created cannot be factored. It is prime. So we are all done with our factoring. So if we want, we can just rewrite it a little more neatly. X minus 5 times x squared plus 5x plus 25. Okay, let's do 2 more examples. So pause the video if you need to catch up with your writing. Okay, so we cannot factor a difference of 2 squares. So for example, if I had x squared plus 16, that could not be factorable unless we involved imaginary numbers. But we can factor a sum of 2 cubes. 729 and 8 are both on my list of perfect cubes. And both of the exponents I see here are divisible by 3. So this is a sum of 2 cubes. So let's dive in. Okay, so we're going to cube root that first term. The cube root of 729x cubed is 9x. When you cube root the 729, you get 9. Cube rooting the x cubed, you're going to just end up with an x. Okay, let's cube root the 8y to the 6th. So let's go over to the right here a little bit. And when we cube root y to the 6th, you divide the power by 3. It should make sense because earlier in the year we learned that that radical can be written as y to the 6/3 power over root. And that just reduces to y squared. So when you cube root y to the 6th, you divide the exponent by 3. So cube rooting that 8y to the 6th, we get 2y squared. Okay, we're ready for SOFAs. Now remember when we do SOFAs, we refer only to this binomial here. We don't refer back to the original problem. So S, the first S stands for square the first term. Squaring the 81, squaring the x. The O in SOFA stands for opposite sign. So if we look at the sign here in the first binomial, it's a plus sign. Let's do the opposite sign over here, which would be a minus sign. F stands for first times last. So multiplying, we get 18xy squared. The next A is always add. And then let's square that last term. We square that last term, we square the 2, and we square the y squared. Y squared times itself is y to the 4th. Beautiful. Okay, we're not going to do this on the other examples, but I just want to show you that when we check the answer, we do get our original problem. So this is a little bit of work, but hey, we're going to do it anyway. You are worth it, Math Star. You are worth it. Okay, so let's distribute the 9x over here. So when we distribute, we're going to get 729x cubed. Distributing again. 9 times 9 is 81. So 9 times 18 would be double that. 162. And then the x times x gives me x squared, and then we have a y squared. Okay, smaller number, thank goodness. 9 times 4 is 36, x, y to the 4th. Whoa. It's going to be a big problem. We got it, Math Stars. Okay, now let's distribute the 2y squared. So distributing the 2y squared, 81 doubled is 162. Oh, so we have a plus 162x squared y squared. Sneaky and fabulous. Distributing the 2y squared again. 2 times negative 18 is negative 36. Got an x. And a y squared times a y squared is again y to the 4th. Whoop, whoop. Looking good, looking good. Distributing again the last term, 2 times 4 is 8. And then adding the exponents on the y's, we get y to the 6. So we got a little cancel, cancel, another little cancel, cancel. And we do end up with the original problem we started with, the 729x cubed plus 8y to the 6. Excellent job. So this down here, this was just our checking. But this is the final answer to that factoring problem. All right, got this problem messed up here. Okay, pause the video and try the last one. I'm serious, pause it and try the last one. Okay, hopefully you did what I said and paused it and tried it. Ooh, what? What? Look at those big exponents. Yeah, dog, we can do this. Remember when you cube root something, you divide the power by 3. So the cube root of x to the 9th is x cubed. The cube root of y to the 12th is y to the what? What is it, math stars? 4th, yes. Z to the 30th, that's too big. We can't do it. No. We better save that for pre-cal. What are you talking about? Of course we can do it. Cube rooting z to the 30th is z to the 10th. All right, let's factor this guy. So when we factor, again, if it's a sum or a difference of cubes, and I can tell because 216 is a perfect cube and the powers are all divisible by 3. When we factor a sum or difference of cubes, we're going to have a binomial and a trinomial. Let's cube root that first term. The cube root of 216 is 6. Then we have x cubed y to the 4th. Minus, we already, over here on the right, we already cube rooted z to the 30th and we got z to the 10th. Okay, it's time for sofas, baby. Whoop, whoop. Yeah, we got this. So we're ignoring that original problem. We're only looking at this new binomial we created for our factoring with sofas. So we're going to square that first term. We have to square everything, the 6, the x cubed, and the y to the 4th. 6 squared is 36. When you square the x to the 3rd, you're going to double the exponent. The reason is if you square x cubed, you multiply those powers. A power to a power, you multiply those powers together. And then when we square y to the 4th, we get y to the 8th. Okay, square the first term. Opposite sign. Now we're just going to do first times last. We don't double it like we do when we square binomial. We just do first times last. So it's just going to be 6x cubed, y to the 4th, z to the 10th. Square the first term, opposite sign, first times last. Always add, and then square the last term. And so if I have z to the 10th and I square that, I multiply a power to a power, you multiply those powers, so we get z to the 20th. This guy is not factorable. So our final answer is just this big, beautiful factoring problem that you see here. Okay, I need you to write me, just like last week, an amazing 8-sentence long essay summarizing what we did in the notes, or an 8-line poem, or an 8-sentence long story, minimum of 8. It can be longer. So upload for me, please, a photo of your notes, and you can go ahead and write your story or summary right in your journal and upload that for me also. This 6 weeks, you'll have 2 major grades. The major grade for this, the first major grade is the performance task that's uploaded in this module. So that's due at the end of the day, Thursday. And these notes and your summary are a daily grade. All right, math stars, take care. Keep it honest. I care about you. Hope you're doing well. If you need any help, feel free to message me. Thanks, guys.